I'm zooming in on the map and we can see some dots which represent some ships. Their position is coming from the AIS signal which they permanently send out, and we know where they are. Every one of these ships has mounted a crane, offshore crane, and we can click on an individual ship and we see some picture coming from the AIS information and their code, and we can monitor 4 or 5 different ships which are registered in this solution here. We get telemetry data for all the different cranes in real time, and we get average, maximum and minimum values of them, and we can look in the map and the graph and see some current values. In addition to the real-life models, we also have a fischertechnik model crane added to the list here, and we can access its telemetry data by switching to the crane itself. And as you can see, we get real-time data of this model here. I'm showing here some live demonstration of some movements of the offshore crane model, where we can see here it's a knuckle boom crane, and I'm moving manually with a joystick the crane upwards, the main jib, also the knuckle jib. It features a complete winch, some meters of wire, and it can turn around with a king. It's more or less a full model. We have some overload sensors and so on, and I'm moving it a bit around, back and forth, up and down towards the camera. And live you can see the telemetry data, the history coming, some seconds lag in between. They are not connected, the screen behind and the crane itself, only through Microsoft Azure, where the telemetry data is sent to. And we have an algorithm. When we move the crane, we simulate that the hydraulic pressure gets lower, and with the pump building up the pressure again, the temperature increases, and we see here the green curve is getting lower and the black curve in the end will increase in value. At the same time, the 3 different dials in the bottom here will show the average is getting lower and lower. The minimum value will get also lower now. The maximum value is fixed since we don't exceed the maximum here. So after some movements with the crane, you see that now the temperature is rising according to the algorithm we have. I do some more movements. The crane model is sending its telemetry data every half second, so we get a lot of data. The visualization here in the dashboard is updating every 2 or 3 seconds only. Now you see we get the temperature rising and the pressure falling. If we wait a bit more, we see we come up with the pressure, and the temperature actually is the critical thing, up to 60 degrees. And with 60 degrees hitting the line here, you will also see on the left side the alarm history that the alarms are starting to tick in. So we are now getting from the system itself with a limit, hey, 60 degrees is reached, so we're getting alarms as long as the temperature is as high as or higher as 60 degrees. You see now also the curve is still rising up to the maximum, while at the same time the pump is building up the pressure again and so on, and the cooling device and so on. So after waiting some time, the pressure builds up and the temperature is beginning to fall again, and as soon as we come under 60 degrees again, the alerts stop coming in. While we are waiting for the temperature to drop again and the alerts to stop, just some more information with the kind of data which is sent with the telemetry. It can be pretty much anything. The dashboard here shows just some 2 key values, the temperature and the oil pressure. It can be different alerts when we have an overload or something. We can also, with the same solution, it's possible to send data back to the crane from the dashboard. There's a possibility to show, to turn on and off the floodlights, to put the crane in a parking position, etc. It would also in the same way be possible to update the firmware of the software control system. And with all this data, you can also feed the whole information into the machine learning part using Hadoop or other services to recognize and identify patterns in usage or other behaviors in the system leading to critical situations, errors, and so on. The black curve showing the temperature is now falling below 60 degrees again, and the alerts stop to trickle in. I'm moving the crane a bit more, and you will see immediately that the reaction in the temperature and the oil pressure curves shows up in the dashboard. Next, I'm simulating an overload situation by pulling manually on the wire. A sensor in the crane registrates that, and you can see the blinking light showing up. In the dashboard, the temperature will rise up to a maximum. At the same time, the alerts will start to trickle in again, indicating that there is an issue with the crane. In addition to just showing telemetry, we also have integrated the whole thing to the PLM system. You can just click on a crane and access directly the drawings used for production of this particular crane. The same thing is also that you can access the 3D visualization data of the crane. As you can see here, an example in Creo view, coming directly from the PLM system, which is connected with the Internet of Cranes demo solution, or the showcase here. Another extension would be to access directly the pending changes, or have the possibility to create new change notices or problem reports on specific cranes. In the showcase, you can also manage the registered cranes. There are 5 different ones, as you can see in this list here. This completes the showcase. For more information, please don't hesitate to contact us on nexiles.com. Thank you for your attention.